All right, let's just go over this warm up here real quick. Make sure, again, make sure you're defining it. So the true proportion of high school graduates who went to college. You want to have the context here. This is about a proportion. It's about the 0.4. So only 40% of college has the percentage changed. It doesn't tell us direction. So we have P equals 0.4, P not equal to 0.4. Okay. This one right here, we want to make sure that over 60%, so again here P is the true proportion of people who like the flavor, over would be greater than, so I've got P equal to 0.6, P greater than 0.6. Alright, production managers. Alright, so this one they want you to write out the type 1 and type 2 errors in context of the problem and then the consequences. So remember your type 1, so this is what the hypothesis would look like. If there's an increase in the proportion defective, then they're going to reject. So P is the true proportion of defective items. So type 1 error is that you reject HO, but it was actually true. So if I reject it, then I think that this is true. So he thinks the proportion of defective items has increased, but really it has not. Remember, we've made an error here. So he stops the production line, time and money are wasted, and production is halted. And at type 2, we don't reject it, but we should have. So we don't think the proportion has increased. We just think it's normal. But it really did increase because remember there's an error. So he doesn't stop the production, but the product is actually faulty. All right, so let's look at these notes here. All right, so just like we've had last chapter, we have conditions again. So just like last chapter, we have our random check, we have our normal check, we have our independent check, our 10% rule. So random, the normal check, we're going to go back to what it actually was. This was back in chapter 7 when we first learned about sampling distributions. And then we have our independence, which is our 10%. So if we think about Jack yesterday, so remember he was going to get 56.56 of the vote. So they did take a random sample, because they took a simple random sample, SRS. I would check my conditions here, just like last chapter. You can't just say, that n times p is greater than or equal to 10. You have to actually show that you checked the conditions, okay? So both of those are greater than or equal to 10, so that tells me that my sampling distribution of p hat is approximately normal, so that's going to allow me to use the normal probabilities when I want to find my p-value. And then the independence, so that's that 10% rule. So he took 100 voters, so we need to assume that there's at least 1,000 voters for this condition to be met. We took a sample without replacement, okay? All right, your test statistic. We talked about this a little bit yesterday. So your test statistic, it's just a z-score. So it's the distance your sample value is from what you would expect. Remember, you're just calculating how far away is the value from the mean, or in this case, it's the value from the parameter. So it's the statistic minus the parameter divided by the standard deviation of the statistic, okay? Is it on the formula sheet? It's sort of on the formula sheet. So on the formula sheet, it's just written kind of like how I've written it here, so it's pretty generic. So you're going to have to piece it together to kind of figure out what it is. So back to Jack here. So again, the formula, the generic version that's on the formula sheet looks like the statistic minus the parameter divided by the standard deviation of the statistic. So if I am talking about p hat, the statistic is p, the parameter is p, the statistic's p hat, the parameter is p, the standard deviation of the statistic is the square root, so of the statistic, that's my of p hat, so it's p times 1 minus p over n. So then the p hat in this problem was the 0.56. The p was the 0.5. And then down here I'm using that 0.5. I do the math here, I get 1.2. I've converted that to a z-score. In this problem, your test statistic, So your test statistic is essentially your z-score. So that's my z-score. So then if I want to find the probability, so remember Jack, he thought he was going to get more than 50% of the vote, so greater than that. So when I find my p-value, I want that test statistic or higher. Again, I've converted it. So I have normal CDF, lower bound 1.2, upper bound positive infinity, mean standard deviation. I get that p-value, okay? If I were doing this test at the alpha equal 0.05, this number is greater than that, so I would fail to reject. All right, remember from yesterday, p-value less than alpha, we reject. P-value greater than or equal to alpha, fail to reject. Okay. All right. The way the book does it, it kind of pieces it, and then we put it all together. So now I'm going to put it all together for you. So when I put it all together here, so when you're starting off here, you're stating like at what hypotheses do you want to test, and at what significance level, defining these parameters that you are going to use. So in this one, I realized in your notes it looks a little different, but it's all still here. All right, so in this one right here, so P is equal, so your knowledge is going to be P is equal to something. Alternative, P is greater than, P is less than, P is not equal to. And then again, you're going to define what P is. P is the parameter, okay? It's from the population. If the problem doesn't give you a significance level, in this step you want to pick one. Most often the default will you'll just go with 0.05. You could pick any of the most commonly used ones, but probably 0.05 is your go-to one. All right, so that's your first step. Your second step, your plan step. Your method is a one sample z-test for proportions. Random. So you want to check, do you have a random sample or do you have an experiment that was randomly assigned? Normal, you want to check your normal check. The independent, you want to check your 10% check here. You want to calculate, now we're moving on to step 3. You want to calculate your test statistic. You can find your p-value using normal CDF. Remember, if your HA is greater than, your p-value is over here. If your HA is less than, your p-value is in this tail. And this is like your test statistic, your z. This is your test statistic, your z. If you're not equal to, you actually have to find the p-value in both tails. So you have like whatever the test statistic is, and this would be like the negative version of it, or vice versa. So you find both tails, okay? All right, this right here, I tried to keep this pretty much the same. So if you're given a significance level, compare your p-value to alpha. If you're not given one, make sure you state your chosen level up here, like I just said, and then use it here. So then just compare your p-value to alpha. State if you're going to reject or fail to reject. Again, if your p-value is small, the result's not likely to happen. So then if it's less than alpha, you're going to reject. And then your final piece is in reference to HA. You either can conclude or you can't conclude. Okay, so let me do this American Idol one with you. All right, so we've got American Idol. Shows contestants often wonder if there's an advantage to performing last. So to investigate this, we take a random sample of 600 American Idol fans, and they're shown the audition tapes of 12 never before seen contestants. For each fan, the order of the 12 videos is randomly determined. So if the order of performance doesn't matter, we would expect approximately 1/12 of the fans to prefer the last contestant they view. In this study, 59 of the 600 fans preferred the last contestant they viewed. Does this data provide convincing evidence that there is an advantage to going last? test the alpha 0.05 level, follow the 4-step process. All right, so my HO. So again here, remember that the P in this one is the true proportion who prefer the last contestant. All right, remember they think that maybe there's an advantage to going last, so we would think that the proportion, the true proportion who prefer the last contestant would be greater than 1/12. All right, I'm doing a 1 sample Z test for proportions. Random. Yes. Stated. All right, for my normal check. So I'm taking the 600 times the 1/12. This is my N times P. So I get 50 right here. And then my N times 1 minus P. So both of those are at least 10, okay? My independent check. We took a sample here without replacement, so we need to assume at least 6,000 American Idol fans. Okay, not true anymore, but let's just pretend. All right, when I do the problem, or when I do the calculations here, so I'm using Z. It's my P hat that's first, so that's 59 over the 600. Minus my P divided by the square root P times 1 minus P over N. You type that all in the calculator and you should get this answer. If I want to find my p-value, you don't have to draw the picture on these ones, but I'm going to just illustrate it here. So if I'm going greater, so 1.329, so I would do normal CDF 1.329, that's my lower bound, upper bound positive infinity 0, 1. So you should get 0.0919 for this one. All right, my step 4. So again, I've given you like just a set of rules here to use. So compare your p-value to alpha. So in this one we have an alpha level. So in this one, this is greater. So the p-value is greater than alpha. So if it's greater than alpha, then I'm going to fail to reject HO. And then like I said here, so I fail to reject, so then I'm going to say I either can conclude or I can't conclude. In this case, if I'm failing to reject, so I'm not rejecting this, I can't conclude that. And this is where I want the context. So there's not enough evidence to say the true proportion who prefer the last contestant is greater, remember this is the HA, than 1/12. Okay? All right. Pause the video and attempt this last example here. And assuming you've paused the video and you're attempting the example by yourself, because that's how we learn when we, push ourselves to think. All right, P is the true proportion of expense records that begin with a 1. There's my HO. They're just saying it's different. They're not saying the direction. So not equal to. They didn't give me a significance level. I'm going to pick one here. Here's all my, remember I'm using P there. I'm not using P hat. Here's my conditions. All right, I'll talk about this part over here in a second. So I calculate my test statistic. Plug it in. All right, now with this one right here, this is a two-sided one. So when I am finding that p-value, I am thinking about it being in both tails. So here's the negative number I found, and then I'm thinking about the positive one. If you notice here, what I did is I only found the area on this side, and then I doubled it. You could find the area of both of them, add them up. You could find the area of this side and double it, but because it's symmetrical once you have it into a z-score. But since it's a not equal to test, you've got to find the p-value in both tails. And then I can conclude. So the p-value is less than alpha. There is enough evidence to conclude the proportion of first digits that are 1 is not equal to 0.301. So they should do a more thorough investigation. I just added. So again, in this case, I rejected my HO, so I do have enough evidence to conclude HA. All right, this stuff that I have under this yellow paper. Okay, you have an option here. You can replace this piece right here with the calculator command. And if you use the calculator command, this is what I'd expect you to write. So on the calculator, we're going to go to stat. We go over to tests. Number 5, it says 1 prop z-test. The 1 is because we only have one sample right now. Prop, because we're working with proportions. Z, we're using the z distribution. Test, we're doing a test. So I'm down here at number 5. The P naught is whatever the number is in your hypotheses. If you notice, these two numbers are always the same. Don't make them different. The X, so 68. N, 300. So the X, so X is my number of successes. So here, we've got 68 successes out of 300. This line right here, look at your HA. Whatever your HA says, that's what you do. This one, whatever, if you're going to draw it, the color is important. If you're not drawing it, the color is irrelevant, okay? So we hit calculate. It spits back out the HA. There's my test statistic. Underneath it is my p-value, same p-value. That gives me my p hat, so that's that 68 divided by 300. There's the n again. You just need to write down your inputs and give me the z and the p-value, so the test statistic and the p-value for your outputs. So like I said, you could replace this whole piece. So all of that you could replace with just this if you want. All right, tomorrow we'll do the same thing, but for the means.